So last unit deals more with circles. So our circle test on the Friday before break hopefully was okay. I mean, I haven't graded it yet, but as soon as it's graded, hopefully it'll be okay. We're going to look at some vocabulary for circles. This will help us through the rest of the semester. What is today? All right. So our first vocab word is a chord. So a chord is a segment whose endpoints, lie on a circle. So it's a segment whose endpoints lie on a circle. So for example, this would be a chord. You start on one side of the circle and my endpoint lies on another side of a circle, the other side of the circle. There's a chord that we've been dealing with, but we don't call it a chord. Can anyone think of what it is? The diameter, right? The diameter is special though. It starts on one side of the circle, it goes through the center and ends on the other side, but it's still a chord. The endpoints of that chord are on the circle. So far so good? Okay. We've also talked about a central angle. So a central angle is an angle less than 180 degrees whose vertex lies at the center of a circle. So an angle less than 180 degrees whose vertex lies at the center of a circle. So if that is my center, a central angle would be here. I'm going to use a different color. This would be my central angle. Can anyone name that central angle for me? There's two different ways we can name it. Okay, so we can name it as ACB. I guess there's three ways. ABC or ACB, angle BCA, or what's the last one? Angle C. Now, if we're going to use angle C, we need to make sure that there's no other central angle being used. So if I drew in another line here, there would be another angle. I could no longer call it angle C. So as long as there's only one, we can use C. If you're not sure, just use the three letters. Okay, remember the angle that you're naming should be in the middle. The letter that you're naming should be in the middle. Still okay? Okay. An inscribed angle. So an inscribed angle is an angle whose vertex lies on a circle and whose sides contain chords of a circle. So the vertex lies on the circle, and the sides are chords of the circle. So my inscribed angle is going to look something like this. Let me call it something different. So this would be my inscribed angle. Can someone name the angle for me? The inscribed angle? Angle Y, okay. What else could I name it? Angle XYZ or ZYX. Good. So that is my inscribed angle. That's this angle here. Now the sides are chords. What are the two chords of this circle? XY or YX, either way is fine, and ZY or YZ. Okay. Questions so far? All right. An arc. So an arc is a continuous portion of a circle consisting of 2 points called the endpoints of the arc. And all the points on the circle between them. So a continuous portion of a circle consisting of 2 points called the endpoints of the arc and all the points on the circle between them. So let's look back at our central angle picture for a second. My arc for my central angle picture is arc AB. We're going to start and go clockwise. Okay, so my arc, so I'm going to just reference it as this. So central, if I can't spell right now, central angle pick. My arc is AB, and that's how you're going to label it. So AB. Again, we're going to go clockwise. So for my inscribed angle picture, what would my arc be? Remember, we want to go clockwise, so we're going to go ZX. Okay. There may be a time where they give you a point in between, and we'll see an example of that at some point. But they may give you a point here, and we'll call that R for now. So my arc would be ZRX. You have to include that point in there. Okay, and we'll look at more at that in a second. But we're going to go clockwise when we name our arcs. And then you need to make sure you put the arc on top for notation. All right. Do I have enough room for this? Yeah, I think so. Then we have something known as a minor arc. A minor arc is an arc whose points are on or in the interior of a corresponding central angle. Minor arc is an arc whose points are on or in the interior of a corresponding central angle. So looking back at my central angle, AB would be considered the minor arc. Okay. Now there is a formula that we're going to kind of need for this. So, and this I would put in bold and make sure you know it. The measure of the minor arc is equal to the measure of the central angle, which we've already talked about. Remember we talked about that in the last unit when we did sector area and arc length? So the measure of the minor arc is equal to the measure of the central angle. This is important. The measure of the minor arc is equal to the measure of the central angle. So if the central angle is 50 degrees, what's the measure of that minor arc? 50 degrees. If the measure of the minor arc is 22 degrees, what's the measure of the central angle? 22. Okay? The minor arc and the central angle are always the same. They're always equal to each other. Questions on that? Okay. I need to flip over. We also have a major arc. So a major arc is an arc whose points are on or in the exterior of the corresponding central angle. Okay, so here's the circle I'm going to give you. Can anybody name the major arc for me? What would the major arc be? Any guesses? D to B?
D or to A.
D to A? Just this piece here?
Yeah, or B to A.
Okay, so it's going to go B to D to A. It needs to go all the way around because it's basically everything but that minor arc. So the major arc in this case is B. We're going to include D and A. So this was the example. If there's another letter in there, you're going to include it. Okay? It's the outside. It's not what's directly in front of the central angle. We know that circles have a measure of what all the way around? 360 degrees. So if I want to know the measure of the major arc, or even the minor arc for that matter, so if I know the minor arc is 25, how would I find the major arc? 360 minus that 25. If I know the major arc is 125, how would I find the minor arc? 360 minus 125. Okay, so you need to know that an entire circle is 360 degrees. I will say that the math for this unit is not difficult, but you have to know the vocab. If you don't know the vocab, it's going to make it hard. Okay, it's a lot of adding, subtracting, multiplying, and dividing. That's the math that you're doing. But if you don't know how to set it up because of the vocab, then you're going to struggle. Still okay? Okay, a couple more definitions. A semicircle. This should be familiar. Who knows what a semicircle is? Half a circle. So, formal definition, a semicircle is an arc whose endpoints are the endpoints of a diameter and does anyone know the measure of a semicircle?
180.
Good. So the measure, of a semicircle is 180 degrees. Can you name, now there's technically two semicircles here, right? You have two halves. I want you to name the semicircle that involves the letter D. What would be the name of the semicircle that involves the letter D? B, D, A. Okay, it's this whole half here, and remember you're going clockwise. B to D to A covers that whole half of a circle. So, BDA is my semicircle, and we know that equals 180 degrees. Now this is also a semicircle, A to B, and I could have named AB. A to B would be this half here. Okay, so BDA is this half, A to B is this half. We're going to name clockwise. Two more definitions, and then we're done. Adjacent arcs. Who can remind me what adjacent means? Next to. Okay, so adjacent is next to. Adjacent arcs are arcs of the same circle that intersect in exactly one point. Oh, dang it, I messed up my colors. This is an E up here. Can we name the two adjacent arcs? The arcs that are right next to each other. What would the two adjacent arcs be? Give me one of them. Let's start there. E to F would be an arc. Yep. What arc is adjacent to EF? What was that? DE. And it says it should have one point that intersects, right? So E is that intersecting point. So EF and DE are my adjacent arcs. Okay. An intercepted arc. Consists of endpoints that lie on the sides of an inscribed angle. So we talked about what an inscribed angle was. Now, here's we have an important formula with this that we have to know. The measure of an inscribed angle is equal to half the measure of its intercepted arc. So the inscribed angle is equal to half the measure of its intercepted arc. So first things first. What is my inscribed angle here? And I want you to name it with 3 letters. Inscribed angle.
B to DJ.
So angle BDA is my inscribed angle. That's this angle here.
So it's D-Day.
Okay? And now I'm reading off of this. That is equal to half of the intercepted arc. What is my intercepted arc in this picture?
DJ. B to D.
Okay, so an intercepted arc consists of its endpoints that lie on the sides of the inscribed angle. So here's my inscribed angle. Here are the endpoints. So the intercepted arc is AB. It's the arc that that inscribed angle creates. Okay, so the inscribed angle is half of whatever the arc is. So if this arc is 100 degrees, what is this angle going to be? 50. Okay, it's half of, the angle is half of the arc. If I tell you the arc is 25 degrees, what is the, I'm sorry, if I tell you the angle is 25 degrees, what is the arc going to be? 50. Okay, so think about that for a second. If this angle is 100, you said, I'm using the wrong words. If this arc is 100, the angle is 50. It's half of it. If this angle is 25, to get to the arc, I would multiply by 2. So if I look at this equation, how do I get AB by itself? What would I do to get AB by itself? Divide by 1/2, which is the same as multiplying by 2, right? So we could say 2 times that angle is also equal to that arc. So depending on what information we're given, and we'll look at this more in a couple days, but depending on what information we're given, we'll determine what formula we're going to use there. Okay. But you should be able to identify arcs and angles. That's what I'm looking for today, being able to identify and name arcs and angles. Questions, comments, concerns?